And I gotta get Chandel. Here, campaign chair. You want to take care of it? You want her, really? I know, I need Chandel and Jen, right up there at the back by Blake. And I don't think anybody else.
Make sure they're in your district first.
I know they are. Those are the only two, and I just got Cam. And I don't know who else is here that might be able to sign. I think that's it. Ooh.
After you speak before questions. Yeah, I'm going to ask you that. Okay, we're going to start. If anybody would like, you can move down, please. There's so few of us here, so it'd be nice. You don't have to for sure, but if you'd like to, come on down and join the crowd. Okay, well, good evening and aloha. Thank you so much for coming out tonight on this special Easter weekend. I know there wasn't the best notice for this event, but it'll be very special. So thanks for being here. I think you get a lot out of it, for sure. Just in case you don't know this building, where you came in, if you went out the hallway to the right and another right, that's where the restrooms are. So I have a couple announcements to make before we start the meeting, and they're both about events coming up. The first one is a debate, and it's being presented by the AAWU-UHH Women's Center. And it's going to be a panel debate on GMO. It's going to be in this room at 4:30 p.m. on May 29th. Okay, so the speakers are going to be 2 and 2. It's going to be Russell Nagata and Richard Ha on the pro, and it's going to be Hector Valenzuela and Margaret Willie on the other side. So that should be a good one. The second event I'd like to tell you about is one that involves Dr. Tyrone Hayes. I don't know if you read about Tyrone Hayes, but he is a professor of biology at the University of California in Berkeley. He has the dubious distinction of spending 15 years studying atrazine, among other things. He was contracted by Syngenta, and he came up with some results that they did not like. So he has quite a story. It was published in the New Yorker magazine in February, and you can look it up. It's under a valuable reputation. But it's quite a story of essentially corporate corrupt science and politics. So it's going to be a really interesting one. We're so glad to have him. He's going to also be in Kona, and he's going to be here on this room again on the 19th of May, and it's going to be at 7 o'clock. Those are both. That's kind of a tentative, and we're not sure where he's going to be in Kona yet. So you might want to check on those if you put those on your schedule for coming to this event. There's some information, a poster back there, and the article that was in the New Yorker magazine on Tyrone, so you can check that out if you would like to. I'd just like you to notice that there is a table back there, all kinds of handouts and information and things like that. This presentation tonight is being put on by Hawaii Seed and GMO-free Hawaii Island. We are basically a pretty grassroots group. We want to keep this island GMO-free. We are an eclectic group. We all come together for different reasons which touch us deeply. It can be biopiracy, it can be human health, it can be environmental health, and of course it might be the big monster in the room, the corporate takeover of the food supply, all those things. But what we have in common is, for the most part, we are not doctors or biologists or scientists or any of that stuff. So we often get trashed as being hysterical or being Luddites and all that kind of stuff. So the man who's speaking tonight has none of those problems. He has credentials. Three pages of credentials. Dr. Lorrin Pang has joined us. He is articulate, he is knowledgeable, and he is a doctor, an MD. He is also a medical researcher. He is also a consultant to the World Food Organization. He is also a genetic expert. and on and on. Currently, he is the head medical officer at the Maui Department of Health, correct me if I'm wrong in that. And just want to let you know how courageous we feel he is. You know, he's in government here, and we all know that this state, agriculturally anyway, has the power to be as the C corporations and their contributions. So you don't usually find people employed by government speaking out. But this is his conscience, this is what he thinks is wrong, and he's here to share that thing tonight. So I just think it's really important that we recognize that courage, and I also think that he's just, myself, maybe he's a local treasurer. So anyway, please give a warm welcome to Dr. Lorrin.
Thank you. Let me just remind everybody I speak as a private citizen. I come every 6 or 7 weeks to the Big Island because I have a small quarter-acre up in Volcano off the grid. I just sit around and watch the ohia trees grow. My daughter said, you will not cut any tree, you will not level the land, and you will make it habitable for our college classmates within 1 year. All I said is you will help, and they help, and we're fine now. They come up regular college kids, and once in a while we might drop down to see Jim. But it makes it very nice. Our neighbors from England, and I have to tell you a funny story. I mean, it is Easter. We're not here to just flower all the time. One day I couldn't find my daughters. You know, we're trying to put up these, it's 8 by 8, but it's 2 stories. They wanted to be in the trees. I couldn't find them. And so the neighbor who's from England, turns out she invites them over in the afternoon for tea. And they go, not for the tea, but it was cream puffs. So I said, wow, okay. So, you know, every time I go now, I have to bring stuff for the neighbor, whether it's like mango or whatever. So I just wanted to tell you a little bit, I guess, about myself. My mother's from Paia. They came over with a sugar company, and they were hit by 2 tidal waves, and they were fed up, and she finished school, college, and she went to meet my father, who was a duck farmer in one of the back valleys of Honolulu. Well, he died in the swine flu epidemic in 1918, my grandfather. And so the stepfather, because, you know, there were 7 kids, and a single mother in those days couldn't make a go of it. So he came over, and, you know, the old stepfather, stepson syndrome. So he was quite a sharp guy who felt that life owed him a little more. But it turned out he was a very good mahjong player, and they opened the house. They ran the house. This wasn't just any old mahjong, the guys ran the house. And so my dad, being in a trusted family, helped run the house. Then the Vice Squad cracked down in 1930, and no more gambling. So they said, oh, what you gonna do? I'll open a restaurant. And people said, yeah, you're gonna have a cook. Well, he did. And it was quite a small, famous Chinese restaurant, but he missed gambling, so he went to Mexico, and he died in Mexico gambling. So that's a little bit about me. I have to tell you, I've joined this listserv, this international listserv, in the last 3 weeks. And all this stuff is coming across, and so I could give you the canned talk. I will give you this little bit canned talk. But since you're here, there's got to be something new, something cutting edge. So I think last night I called myself a Luddite. I didn't know what Luddites were. They're supposed to be dumb people who don't think forward and all this. And actually I was called a Luddite, and I wear that with distinction, because the reason they call me a Luddite is for the following reasons. The GMO industry, I used to call them the GMO industry. Then they named themselves biotech. At one time, they called themselves the life industry or something, whatever, life industry. But that was too gross. That was too out of sync. So they call themselves biotech. And so when we argue against the biotech industry, people ask me, so are you against biotech? Well, what does biotech sound like to you? It sounds like, to me, technology in the field of biology. That's like a needle and syringe. Technology, that's pretty good technology. Sterile needle syringe, sucking up on a vacuum in the name of biology or medicine. So I said, well, you must be against needle and syringes. You're a Luddite. So I said, so be it. If I'm against needle and syringes, I'm a Luddite. But I'm not against needle and syringes. But then you're against biotech. You get the idea. If I was pro-invasive species, I would call myself pro-life. Okay? And how dare you? But I'm just a category. So that, I mean, to name yourself the biotech industry is a little weird to me, but the name stuck and that's how we refer to them. You can call them a special branch of the biotech industry, that's fine. The other thing I wanted to tell you is like, it kept me up all night last night. I was up in Volcano trying to sleep, and the phone keeps ringing because Australians are out of sync, the Europeans are telling me Happy Easter, and I just had this thought. So we're trying to get the thoughts straight here. Look, it's nothing really more complicated than a car and a horse. A lot of people said, isn't it true that biotech can produce a whole lot better than regular non-biotech? Well, in the right situation, it could. It's almost like, now maybe you can't read this, but this is the special, this is not the canned lecture. Isn't it true that a car can transport you quicker, farther, faster than a horse? Now pretend car is like GM and horse is non-GM. So isn't it possible that in the right situation, this stuff can actually produce more efficient? Okay. But what's the problem here? I claim that the car, I kind of know what a car is, and I know the risk and benefits. I know it's kind of safe, and every time it's not safe, the ignition messes up. These guys recall it. I have faith in the industry. They label it. You know, when it says the Toyota car ignition is having problems, the GM, yeah, I said, well, that's a GM car. When the Toyota has gas pedal problem, that's a Toyota, it's labeled. They've recalled things. They get sued if they don't recall it in a timely way. So I kind of have faith that they know what the car is. I don't think the GM guys really know what it is. Next, the car is better than the horse in the system called the roads. To set up the roads, hey, that's not so straightforward. It's the system also called gasoline industry to make gasoline. It's a system called asphalt. So you have to make a special system if you're going to have the car beat the horse. The car surely beats the horse on the road even, if the horse gets to use the road. But that's the other problem. All this infrastructure for the car, do you have confidence in the risk? Well, do you have confidence that the roads are not polluting and going to kill us? Do you have confidence in gasoline industry? You mean in the short run or the long run? You mean fracking? Because we can certainly convert cars to burn. And the asphalt, I mean, at one time asphalt was like creosote. We worried about creosote reaching out. But there's an infrastructure. So what's the infrastructure to support GM crops? Well, I didn't know how bad it was until there was a lawsuit in Kauai, and we were kind of privy to it. Sugar cane, pineapple, how many chemicals did we use? Maybe 15. Currently, how much chemicals are put on the most chemical saturated non-GM crop? Strawberries, maybe apples, 45. Okay. How much chemicals are put in GM crops? This is why the big suit is occurring on what? 90 plus. Now you think, hey, what's the big deal? 90 is just twice as much as 45. Well, I should be able to just spout this out for you, right? With 15 chemicals, pineapple, there are 30,000 different combinations. When I went through school, a combination of 2 chemicals is considered a new combination to proven otherwise. That's 15. With 45 chemicals, I forgot, I think it's like a trillion. Okay. With 90 chemicals, there's a trillion. Okay. Now, like, what are you saying? I'm saying that the risk of unknown toxicity is increasing 1 trillion-fold when you go from 45 chemicals to 90. You will hear them debate me on Maui. You say, come. So you expect the EPA to test 1 trillion chemicals? We can barely test one atrazine. We can barely test one glyphosate, let alone long term. So you're pie in the sky. You're asking us to test so many possible combinations. You're way off in left field. Not true. I can test 500 chemicals at once for you. It's called a lit cigarette. When you burn a cigarette, there's 500 coming out in a soup. I can test the whole soup. I can test a whole bunch. Creosote, that's a whole bunch of chemicals in combination. I can test creosote. So tell me, has somebody tested the 90 chemicals? That's what the suit is all about in Kauai. It wasn't tested, and people are claiming their side effects. Well, should we look? Yeah, we should look. Should we have looked long ago before it kind of comes out there? You will hear many people, politicians, say, we're not taking step one till we see harm. By the time you see harm with these chemicals into our water table, into the reef, into the people, it's pretty late. Okay. Now, once again, I will claim that when you increase the number of chemicals, it's not so hard to test the big stew. But just because you can test once the big stew doesn't mean that the risk is not climbing up every time you got a new combination. Kind of like the car. Today's modern car, we have, let's say, 5,000 different things that could go wrong. I can test the whole thing. I drive twice around the block at night. But just because I can test it in a simple drive doesn't mean that the complexity of the car isn't increasing because you got so many systems depending on each other. So that's the infrastructure that I claim. We don't know about the car. I don't know about GMs. We don't know about the infrastructure. I don't know about the pesticides or the fertilizers or the wild water, blah, blah, blah. So we always look at the benefit. You told me the car can beat the horse. I'm sure it can. But we look at the risk. Okay? I don't even know about these things. I kind of know about the horse. Non-GM plants. This has been going on for years and years and years. We can grow non-GM plants with a whole lot of chemicals. A lot might die. Hey, let's go over this one more time. Non-GM plants, you grow it without chemicals. A lot die. Hey, that's the story of my life. I have 2 acres. I planted 30 different things. All but 3 died within 2 weeks. But you know the 3 that grew? Yeah. I can trade it for more than feeding my family. I grow 3 things well. I do not like the mentality, I'm such a good farmer, I can grow anything, anytime, anywhere. I grow what I grow and trade the rest. Okay? Once again, I grow what I grow and trade the rest. And the amount I grow can certainly be traded for blah, 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 to feed my family of 4. And what I don't, is how I donate. Okay, so let's talk about the risk. There's 2 kinds of risk. The risk to you and the risk to the system. How long can you maintain the roads? How long can you maintain the chemicals before the system collapses? You see drug-resistant weed, blah, blah, blah. That's the risk to the system. You sure you want to invest in the car and the roads? Or GM and all the infrastructure, you sure? Because the system might collapse. But there's the personal risk. Personal risk. That is, if God tells you, this system ain't ever going to collapse. We give you GMC, we give you all the pesticides and fertilizer, and every time it fails, we got a new one for you. Yeah? That's good. There's no risk to the system, but there's personal risk. Because the pesticide blowing off in drift, the water, the soil, the air, stuff we don't even know how it spreads, that's risk. And what happens when you have a great guaranteed system, but personal risk? What do you think? Medically? Ethically? Like if God told you the GM papaya was an absolute winner, it would never collapse. It would keep growing, and whatever pesticides you use, you're always going to get them. They're never going to fail. But you said, well, what about me personally? When that occurs, that means it's released under written informed consent. And I don't recall signing written informed consent. Well, did I buy the GM? Bye-bye. Written informed consent, we tested live vaccines in Bangladesh. The kid getting the vaccine signs, his mother signs, and the whole village signs whether or not they get the vaccine because it's a life form. Life form means everybody signs or not. That's my opinion as a medical researcher. I've taught this subject 20 years for the World Health Organization. I should also warn you that the UH Ethical Review Committee defamed me. They say I cheat when it comes to science. I cheat. I sued, we settled. They decided they never should have said that. Not that I don't cheat, they just never should have said that. Okay, so here I am at UH. I don't hold it personally against UH. I hold it personally against some people in UH, but UH is a big thing. You know, I have great friends, Hector Valenzuela, UH. My students from here, UH. But I kind of don't like to be called unethical or that I cheat. The other thing you should know, last year I'm a professor of medicine, Federal University of Brazil. I've lived there 3 times, so I'm a professor of medicine for Federal University of Brazil. Okay, what else? I'm a consultant to a group called DNDi. These are the drug arm for Doctors Without Borders. They're out there trying to help these people find out no drugs because these people are disenfranchised. Nobody cares about them. So they consult a group to make drugs and vaccines and diagnostics for this group. So I'm a consultant for them. The other thing, this is not a one-upsmanship, but I don't like to be called cheating. I am a consultant for your U.S. Congress, choosing which research to fund, hundreds of millions of dollars a year. There's committees. They're from Yale and Columbia, and they don't care where they're from or where I'm from. They want to hear your ideas. But if you insult somebody, they will ask you, so where are you from? I hate to go to that means. All right, so let's just get going here. I guess we'll dim the lights, and okay. We'll start with the formal thing here. Okay, so this is the canned talk, and I'll add some things as I go along. And okay, so the real issue started with this bill. I think it was on the Big Island to put a moratorium on taro color. Here's your guy from Puna, Jerry Konanui. And we always spoke against genetic modification of plants, but when they started to modify taro, that's when the Hawaiians got really upset because the firstborn of a Hawaiian was a child, and he died, and they buried him, and Haloa, from his grave sprung the taro. So the taro is the firstborn. The secondborn was Haloa, the man. So they always told the Hawaiians, you take care of your brother, he will take care of you, etc., etc. Well, they were going to genetically modify the brother, and they were going to take a patent on that. So that wasn't very good. So the name of the talk is GMOs, Are We Gambling with Our Future? And their answer is no. Okay, whose side are you on? Is this a trick question? It's a trick question, but it's quite correct. Me, I'm a little bit obsessed with definitions, and so I have to say, what's gambling mean? Gambling means, just like Jeffrey Smith, you play roulette. You bet on the black or you bet on the red. If you bet on the black, there's equal number of reds, but there's 2 greens. So you got a little higher chance of losing. So that's how we do it. We bet. And we know the odds of winning, and we know the odds of losing, and we bet. You feel lucky. Okay, so what is genetic engineering? Genetic engineering in the ideal situation. This is what they want, right? All you gotta do is take a foreign gene in red, and somehow you put it into another host. It could be another species. It could be a foreign gene from the spider being put into the goat. They actually did this. You took the spider gene, put it in the goat. Yes. And when things work, that gene, it's read by the gene is the DNA. This big black sequence is the genome, all the genes of the goat and you stuck in the red spider gene, it's read by the goat RNA and it makes proteins, spider web. They took the gene for spider web. Oh, that's pretty cool. You mean the goat, every cell is making spider web? Yep. Well, why do we do that? Well, first of all, it's cool to say you could do it. But you want a lot of spider web because spider web is one of the strongest materials known to man, and they couldn't get enough spiders, so they just milk the goat and pull out the spider web. But every cell in the goat is producing spider web. Gee, what happens if the mucus is too sticky because spider web, I don't know, the goat dies. What happens if the mucus of humans is too sticky? It's called cystic fibrosis, like major problems. If you underrate mucus, you think, that's just mucus. I've been told we produce 5 liters of mucus a day, and we swallow most of it, or it's produced in your gastrointestinal tract, and it's passed that way. But that's how it's supposed to work. You remember? The proteins that spotted red mark, that's what makes you, you. But the blueprint is the DNA, that gene, that red thing, or the black genome. Okay, see that vector? What's that purple thing? That's how you put it in. In general, for plants, they put it on bacteria, and the bacteria goes in and puts it in. Or, more likely, it's called biolistics. You get that red gene, and you coat little particles. I can't remember if it's gold, it might be silver, it might be tungsten, and you put it in a 22 shotgun shell, and you blast it into a dish full of cells. In this case, goat cells. And some of them get there, and some of them don't, and you just blast away. So, what's this other stuff? That green thing, see that green thing? That's called the promoter. It's like an on switch. Why in the world, you mean you can't just put the red gene? No, because in you and me, it changes every day, but it's somewhere between 95 and 98% of our 33,000 genes are silent at any one time. Say that again. Our 33,000 genes, 95%, maybe 98, are silent at any one time. Some turn on when you're 3 years old and turned off when you're 20. Some will turn on when you're 75. You thank God you never get those signals mixed up, because you see these medical abnormal kids. They turned on the 75-year-old gene, and they're small, but they look kind of like apoptosis. They're dying. They turned on the gene for being at 75. Some genes you never turn on. These are called oncogenes. They make leukemia. You turn those on, you bought the farm. Why in the world do we have oncogenes in our gene? I don't know. Okay, I have no idea. But I think they were useful sometime long ago. Or maybe they're useful now. And we're just too dumb to figure out how. So, you got to put the promoter, and then the final thing is the marker, the blue thing. Because when you blast away into a dish of cells, well, how do you know which one took? All you do, that marker usually confers antibiotic resistance. You flood the plate with the antibiotic, and if that construct, the green, red, and blue is working, then it will be resistant, and the antibiotic won't kill it. It's an easy way to harvest. Okay? So, what's the problem number one? That marker, it's like the minor point, but the marker was antibiotic resistance. The medical community is furious. We're having trouble with drug antibiotic resistance, and you went and put the marker in the plant. I got to tell you this, because this is the first time I realized how deep thinking these guys are. I said, I don't think we should put the tetracycline resistant marker, tetracycline. And they said, they flew up these guys to debate. Said, why? Tetracycline is no good anyway. It's already no good. Resistance is already developed. I said, but that's not true. It's useful first-line therapy for leptospirosis, rickettsia, typhus, and malaria. And these guys, now my field is malaria. We publish in malaria. They actually said, well, that goes to show how dumb you are. Everyone knows that tetracycline is not the lead drug for malaria. It's quinine plus tetracycline. It's a thing. Come on. We just published like 5 papers in the last 5 years. It's quinine plus tetracycline. Quinine brings the count down, but it never cures it. Tetracycline takes a little while to kick in, and once it's there, it'll cure it. Now, to tell me, without even doing your homework to figure out who I am, that's pretty heavy. And I realized these guys are going off half-cocked. And so every time we meet, they don't debate me anymore. I ask them, hey, did you ever figure out that tetracycline thing? Because, because you should either apologize or explain to the public why you say these half-cocked things, okay? All right. Now that's the ideal situation. That's genetic engineering. I like that term, engineering. My father was an engineer, and these guys kind of know what they do. Here's what really happens when you blast away. Oh, see that construct? Green, red, and blue? Oh, there it is. There it is. Good. Oh, well look, here it is in this one. These are 2 different targets, yeah? Well, when you put the thing in, did it smash something? I don't know. You just kind of blasted it in. Did it separate something useful or just smash it? I have no idea. Look, here's a loose promoter. That green. By convention, it turns on things to the right. So my right is your left, maybe. Anyway, it turns on these things. You should not turn things on. Hey, yeah, you should not. But there's a loose marker. Oh, look, this promoter turned on these blue things. You turned on a silent gene. I should have made it black, okay? Should have been black genes. Well, what's the silent gene supposed to do? I have no idea. Medical people call them junk gene, junk DNA. We learned they ain't junk. Some of these genes turn on other genes. They don't make proteins, they orchestrate. It's like the conductor of the band. I think you turn on the conductor at the wrong time. And then now this is a mess because I couldn't draw it correctly. The genome is not a linear sequence. It's nice to draw it to say that goes like that. But it's really a confluent folding, 3-dimensional. And these folds have been named. They've been called flip in, flip out. There's no fold called flip off. But there's torsions, twists, and things like that. And it is a beautiful twisting that I couldn't draw it. I just drew it as spaghetti. Trust me, it's not spaghetti. But what's so important about that, Dr. Pang? Who cares? Well, I care. Because, look, when you read the promoter, you can read down the line, or you can read bridging. And we discovered that 33,000 genes make 100,000 proteins. Now, wait a minute. If you said this 15 years ago in college, you get an F. 1 gene makes 1 protein. 1 gene makes 3 proteins because it can read cross-linkage across this conformational twist. Okay? So be very careful on your spacing and your junk gene or junk DNA. Here are some shocking things we learned about genomics in the last 20 years. Number 1, I told you, a lot is silent. I can't get that. A lot is silent at any one time, okay? Well, how do they turn on? Because some things turn on, and they will start this one to turn on, it's orchestration. You know what? Here's this important point because the industry brings it up. Shared. We share many, many, many genes with other animals and other fungi and other parasites and blah, blah, blah. Whoa. You mean our ancestors had sex with their ancestors? No. Probably not. Probably the viruses. And we brought this up with Monsanto when they used to pay guys to come over to talk to us. And they said, oh, come on, Dr. Pang. You mean the viruses shared all these genes? Can you think of one virus that infects different species? Hey, guys. West Nile virus. Almost all species of birds, it kills some and lets others alone. Then it goes into man, dead end, but goes into man, pig, horse, cat, squirrel, whatever. And it's okay, enough. And of course all the mosquitoes, because it goes mosquito, bird, mosquito. But say this kind of stuff after you tell me tetracycline is not the lead compound for malaria. They just don't do their homework. They just kind of shoot from the hip. Or they shoot from the hip in front of an audience. And they say it with such conviction, this sounds right. And can you really think? Yeah, I can. Okay. He said, you guys never did your homework. So the viruses share this, and that's how we get this. Immediately, this is like all week on the listserv. Whoa. Industry will tell you, I am not afraid of picking up foreign genes. Okay? Because my genes are full of foreign genes. What stuff? Not a couple new ones. Really? Well, let's go over this again. It was just published. That the fern gene, they just published this, has a gene from some algae, some fungi. See? It's occurring all the time. What's the little added kick? Well, first of all, that fern gene, to take that algae gene, was over 100 million years. When that gene didn't sit in the right place, or it went to the wrong spot, or turned on something, or it's too big, too small, that line died out. Okay? So your ancestors, you and me, we share genes with earthworm. When that thing came to us, maybe the virus got the earthworm gene. Your ancestors who didn't know how that was, they died out. And what you got left, you have earned, or your ancestors earned for you. I don't want pointing at you. Your ancestors earned that for you. We are attuned to having what we have because it's useful. Okay? You want to bet? Try to move her position, the foreign gene. This is my area in genetics. We share a gene with the malaria parasite. It pumps toxins out. So when we try to block the parasite from pumping out our drug, we block their own liver. The kids almost died. Whoops. So that gene, it's all in one location. It's not willy-nilly in our system. Okay? So your ancestors pay the price. If you want to rush it and blast yourself full of genes, you or your children might pay the price. That would be the dead-end line. They don't get to rush evolution. So the other problem is, I have to bring it up right now. Okay, so gene therapy. The gene therapy fails, and there's many cautions to it. All right, let's talk about this. You don't have to read it. I'll tell you what it was. I told you, try to cross spider gene into goat. Can we even do human to human? No, we can't. It was published in the New England Journal of Medicine, our lead journal. There were two boys in Philadelphia, and they missed a gene, severe combined immunodeficiency. They have to live in the bubble. And they got tired of the bubble. And the researchers said, you know what? We all have the gene for immunity. We're going to take this gene and give it to the boys. Informed consent? Informed consent? Absolutely. You could get messed up. But why would you give the gene without the promoter and on switch? Because it might be silent. We put the promoter. What happened to the boys? This is human-to-human transfer. What happened to the boys? Did they get the gene? That would have been wonderful. They died of leukemia. The promoter turned on the oncogene. And it wasn't just dumb luck. Hit the oncogene. It was fourfold the probability of dumb luck. The oncogenes, the leukemia genes, are waiting to be called. Orchestrate me on. And the boys died of leukemia. So what I'm trying to say is, you might share a lot of genes with the earthworm, or me too. But it's not just that that gene is useful. The guys who couldn't handle it, and your ancestors might died out. But the process of putting it there, I'm sure there was a lot of dead-end promoters who turned on the wrong thing. That line died out too. So the biggest argument right now is, this is natural. It's natural, but somebody paid the price. Also, I don't like that statement, this is natural. Water is natural. In the wrong amount, in the wrong time, that'll kill you. Oxygen is natural. Early newborns, you give them blindness. Salt is natural. It's the timing, the location. Water in the lung, water in the stomach. Too much is too much. I don't like the argument, it's natural, but that's the argument now. You will hear it when I'm not here. First is that, well, and it's not here. Say it's natural. It's natural. Okay. You can say water's natural. Okay. So they told me to stay away from this because that's all genetically engineered plants. All the boo-boos, all the mistakes, all that mess is grown in the field. We watched it for consistency. All that mess, we grow it in Hawaii, maybe not Big Island, but all that garbage is selected out and we get the true blue ones, the consistent ones, or so we think. And so, Dr. Pang, we do plants, you do humans, and stay on your side. Now, we know from humans, gene therapy doesn't work. We can't do human to human. And the medical people have 4 moratoriums. We're not going to do this gene therapy until we know, kind of makes sense, exactly where it goes, exactly what we turn on, and if there's a mistake, we can turn it off or remove the whole construct. There's 4 criteria that the medical people have imposed upon themselves. It's in the New England Journal of Medicine. So, but the plants are plants and humans are humans, and leave us alone. Why, except for this. When they grow it in the fields of Hawaii or anywhere, people eat, breathe, and it's in your water. I'm talking about the mutations. I'm not talking about the pesticides, just the mutations. And this was shown in rat feeding studies. When a rat ate the GM food, it went into the, not the stomach, but stomach cells. And then from there, it went up into the lymph nodes and the blood system. And so that was quick on first feeding. Then the guy didn't take a live rat, he actually took rat cells and human cells in culture. And he showed that putting GM food on, it would go into the cells and was on, it would express. Whoa, even Monsanto did similar work and admits that, yeah, we saw that. So, you know, the stuff is crossing, and I don't think we should eat these things untested, okay? Now, here is, I'm not a Luddite on this area. I have messed with GM vaccines. Our GM vaccine was for hepatitis B. It was made in a bacteria. We put the viral bacteria into the, we put the virus gene into the bacteria, and we pulled out not the mutation, but the protein. We purified the protein, we labeled it. We targeted only people who needed it, and we tracked it. Even after marketing and labeling, we tracked to see if there were side effects. So we did it very cautiously, and when we grew that bacteria with the mutated gene, it was contained in a vat. If it goes outside the vat, it's dead. So that's how we did stuff, purifying and all that, for the vaccine, GM. But what does the guys in the field do? The crop guys, it's in the wind, it's in the soil, it's in the waste product, it's in the workers, it's in the community. Oh, it's in the food. Hey, unlabeled. You ate the stuff. It's in your consumers. Whoa. And what's the scariest thing of all? Trust me, I could go back 3 slides, but besides going off wiley-niley, messing up the whole orchestration, a gene that doesn't belong there has a tendency to want to move out. It's called promiscuous. Okay. So I want you to remember that taking a gene from a spider, putting in a goat, taking from a fish, putting in a tomato, taking from a corn, putting in that, mixing these things up, messes up the orchestration. And a very good way to remember this is band and football. I played in the band. The football team was the football team. And it's like taking the trombone player and throwing him ballistics right into the football team. Now, if he mashed the quarterback, well, you don't have a quarterback. Okay? But the promoter is always on. So here I am playing the trombone. People say, shut up, we're trying to have a huddle. Nope, I'm always playing. Okay? That ruins the orchestration, ruins the feedback. I certainly am not the quarterback. The quarterback is gone. And I keep playing the trombone. Finally, the football team says, enough of this. Well, I'm more than happy to move because I'm the promiscuous gene. I'll move to the girls' volleyball team, see how they like it. And that's how these things transfer. Okay? It's kind of sad, and you think I'm making fun of it, but we actually don't know more than this. So what's wrong with using very simple terms? So the bottom line is I believe in the precautionary principle. I know it's hard to read, but I'll try to explain it. I kind of already explained it. The car and the roads and the gasoline and asphalt. You tell me the benefits, you tell me the risk, I will weigh the risk against the benefits, and we will decide whether to go with cars or horses. The risk, the benefits. Industry repeatedly keeps saying, well, you know, nobody can show safety. Well, They keep saying this to the bill that we put forth in Kauai, the bill we put forth in Maui. Nobody can really show safety. So therefore, we're not even going to try. Guys, how is safety shown? Really, I mean, how is safety shown? A drug, cancer chemotherapy. I'm going to treat your mother. Okay. What's the efficacy, Dr. I think there's an 80% chance I'll cure her with this drug. Are you sure it's 80? Okay, it might be 70 to 90. Okay, but it's 80 plus or minus 10. What's the chance that the drug, the side effect, the safety, is going to kill her? I think it's like 30%. Are you sure it's 30%? Well, it could be 10 to 50. There's uncertainty. Well, I'm not insisting it's 0. I'm telling you it's 30. And I'm telling you the uncertainty. So when they tell you nobody can show safety, I don't know if you mean 0 or you mean the uncertainty is so certain we'll really know. The uncertainty is never 0. When you go to a poll, how many guys don't vote for Obama? And they say, well, 45% with the margin of error is plus or minus 3. Nobody has plus or minus 0. That's a sample of infinite. Okay? So I don't know if you mean a margin of 0 or the point estimate of 45. But certainly, when you say, well, nobody can show safety perfectly, so we don't bother at all. I expect a point estimate of the safety, like 15%, going to die within 6 months of whatever, and that's 10, whatever, what did I say, 16? It's going to be plus or minus 5. I expect uncertainty and the point estimate. I never said it was 0. I never said we knew exactly anything. So they will set up this straw man, because nothing's never known, so we don't bother doing anything at all. That's the most ridiculous thing I've ever heard. So, do we have, based on the precautionary principle, that you know the safety? Now, I know they say they know the risk. That Hector Valenzuela, he'll tell you the benefits, they don't really know. Okay, I worry about the safety. Okay, here's the World Health Organization in 2004. At this point, we have no evidence to say that it's dangerous to consume products that contain GMOs. But at the same time, we also don't know its negative side. So we have to say that we do not know the adverse health effects. This was World Health Organization. What was that, 2004. They will tell you plenty of publications came up since then. You better do your homework. Just go to the Monsanto website. Ask how many human studies out of that added to 0. The head of the medical section of Monsanto, Daniel Goldstein, came up to us to debate with me. And he said, Dr. Pang, there are no safety studies. Oh, stop right there. There are no safety studies. Because safety studies cannot be done. Oh, that's strange. I do safety studies on my drugs and vaccines. He said, no. To do a safety study on a GM food, you gotta give the guy the food, lock him away, and give him for 30 years and do nothing but the food. Because you gotta rule out all that other stuff, right? Well, how in the world did we test the safety of Lipitor, that thing for the cholesterol, knowing it's blocked by grapefruit juice? You give the normal diet, and you put it on it, and you stand back because of combinations. But his point is that since, I'm glad he said it wasn't done, because it wasn't done. But he's saying that it can't be done perfectly, so we won't bother even doing anything at all. So that's like their position. And when they come to debate, you ask them for Monsanto's position. It's nice they would tell you their position, but go ask them. Check out Monsanto's position. It's almost indefensible. So that's World Health Organization. Just out of curiosity, what in the world do they use if they don't use precautionary principle? And I've said this many times. It's called risk assessment. And every time I look this up, I always look it up before I present. And then I always realize I've seen this slide before. It's because I can't remember it because it doesn't make sense. Risk assessment is food, drugs, and vaccines. You're going to take food, drug, and vaccine. I'm going to test it in humans because you're going to take it. Risk assessment is done for stuff like pesticides when people aren't going to take it. So how do you do it? You tell me what the agent is, glyphosate. You tell me a dose response in animals, okay? You tell me how you're going to mitigate, don't spray when the wind's blowing. And the final thing of risk assessment, which is the most insulting thing to a scientist, but Daniel Goldstein put us letter to science. He said, you tell them the background risk. So when we put out these pesticides, what are you worried about? You could be hit by lightning. No, I mean, it sounds ridiculous, but so we will, no, you can see this, strange as it sounds. We'll just like move just right ahead because I'm going to show you this. Scientific American, whoa, these guys show that glyphosate alone is quite safe. There's something called POEA, a surfactant, which allows glyphosate to penetrate the cell. Surfactant alone is quite safe, nothing to penetrate. Glyphosate alone is quite safe, no penetration. But when used in combination, cell necrosis and early cell death, pre-programmed death, whatever, published. Well, no, it's
apoptosis. Apoptosis.
Yeah, there you go. Pre-programmed death, the 75-year-old woman. Well, this is occurring in germ cells. Oh, that's pretty early death. And what? So when they combine it, well, you see this horrible effect. And Daniel Goldstein from Monsanto wrote a letter and a blog. He said, POEA, the surfactant which allows penetration, that's like a detergent. Just like a needle and syringe, it's like a biotech. You bathe in shampoo every day. What's your problem? Well, what does that have to do with that you paired it so it goes in my cell? And it's not a shampoo. Well, shampoos are detergent. This is part of risk assessment. You tell them like, don't worry, you might be run over by a bus. I mean, it's as silly as that, but it's published. You tell them when they debate, quote Daniel Goldstein from Monsanto's position. Okay? Now, so that's how we're supposed to do things, okay? And that's kind of the end of the story. No data, according to WHO. I believe in precaution. You cannot tell me the risk because there's no data. The end. There are some people who are so smart, one group of people, Institute of Medicine, National Academy of Science, they get to give predictions without data. Whoa. No, that's okay. They predict about childhood obesity, Gulf War syndrome. When there's a problem, they call this group, and they said, we know we don't have data, but they're quite recognized as very smart. And so, they put out this position. They wrote a book called Safety of Genetically Engineered Food, Approaches to Assessing Unintended Health Effects. No data, but this graph appears twice in their book. These are all the ways you can modify plants. Up here is select, normal crossing, pollen to pollen, big yellow pumpkin. You get the pollen from the biggest pumpkin, you get the pollen from the yellowest pumpkin, and you cross them for the big yellow pumpkin. And these stars are all the genetically modified ways, GMO ways. So that's all the ways you can do it. On this axis is the likelihood of unintended health effects. Whoa. It's not even linear. Look, the GM ways have a higher likelihood of unintended health effects. We presented this in debate, when we used to debate in Maui, and your colleagues from Maui Community College, CTAR, said, it doesn't say health effects. It doesn't say health effects. Come on, let's write to the Institute of Medicine. The name of the book is on the tail of it. So they don't say that anymore. Okay. Don't say that. Next, Monsanto paid for doctors from Harvard, Duke, and UC something, Irving maybe, to go out to the Hawaii Pediatric Association and show the same graph, because we all like the graph, these are smart people. And they said, there's not one effect that we see with GM plants that we don't see with normal plants. Like GM plant caused nosebleed. We saw that with this plant, the non-GM plant. I said, yeah, I agree. But the GM plants causes more. This is a quantitative statement. And then they have to go catch a plane. So we never heard the end of that. This is a quantitative statement. Next problem, because everyone likes the graph. Somebody from Penn State, very prominent, non-medical, nothing magical about medical people, but I expect some honesty. Somebody, a plant scientist, prominent, said that, Dr. Pang, you're kind of right. These are unintended health effects with GM. There are more. But but they're not all bad. No. Let's go over this one more time. There's more unintended health effects, but they're not all bad. Well, don't forget, I come from a drug and vaccine background. How would you like me to say, Jim, what's your problem? I have kidney problem. Here's a drug we don't know. It's not all bad. Let's say it's equal. Good for the heart, bad for the kidney. And I don't know it, but God tells you good for the heart, bad for the kidney. Shall we give you that? You got bad kidneys. It's going to make your kidney worse. Okay? But it might make your heart better. Your heart's fine. People in normal health don't take medications. I don't actually get this idea at all, that the good somehow outweighs the bad. That's why, just like drugs, we tailor to the guy, what's your problem? We study the drug, good for the heart, bad for the kidney, and say we use it or don't. This is the most outlandish statement I have ever heard. But she's not a medical person, but if she was, you're opening yourself up to liability, and it's wrong. Okay? But it sounds kind of slick, doesn't it? Not all bad. Well, what's what? Please tell me. That's why we got to test these things. That's why we got. And you know, in a normal state of health, I can't make good better, so you're just risking the bad. I mean, that's like weird. Okay, but so next we have our regulators. That was the scenario. What the guys who don't need data, smart people, say. Well, where's our regulators? USDA. This guy Tom Vilsack, a lawyer. Nothing against lawyers, but he said science itself is subjective, and if he could have 3 different groups bring in 3 different supposedly scientific results. I've heard this many times. Science can show you anything. Science can show you anything. Well, first of all, the guy who says it, a lawyer, although he's at USDA, I expect him to have some credentials. The science I taught for 20 years to the World Health Organization students, I don't think science shows you anything. I think that if you do it correctly, it will show you something reasonable. For example, now I don't want to turn on the lights, but I told you I'd bring up new things for you. I had to give testimony before your Senate. Josh Green called a hearing on glyphosate, that pesticide. And they said, oh, sorry, it shows you anything. The Argentinians, they took the glyphosate, not even with the surfactant, and they gave it to young germ cells of chickens and frogs. And in the formation of embryology, there's something called a neural crest. You messed up with that, and you got defects. So in the chickens and frogs that got exposed to glyphosate, they didn't have a brain and a face. Okay? Dr. Carrasco from Argentina published, and he said, I'm really worried about this because this is what we're seeing in the areas of Argentina using excess, plenty, glyphosate, Roundup. It's the soy areas around Cordoba, et cetera, et cetera. This is what we're seeing in the kids, and he's reproducing it in animals. Okay. Well, how much are you seeing, Dr. Carrasco? 5 times normal. Okay. What's normal? What's normal? I guess maybe what, 1, I don't know. I had to look it up. What is the normal rate of this defect? Let's just say for argument is 1%. He's seeing 5%. Okay, it's really 0.5%. He's seeing 4%. 5 times half is 3%. He's seeing 3%. What does Monsanto say? What does the EPA say? In our safety studies, it was perfectly safe. Perfectly safe. Pull the safety studies. Pull them. What'd you do? Did you give it to humans? No, it's a pesticide. So we give it to rats. What's the standard? How many rats did you give? It's not published. It's in Monsanto's private thing. But the limit EPA recommends is 40 rats, okay, or 35 to 40. If you see 0 out of 40, you saw 0. What's the uncertainty of that? It's 0. It could be 0, but it could be up to 9%. So in your small rat study, it's possible to have missed anything smaller than 9. What are the Argentinians reporting? 3%. The data is compatible. Science doesn't show you anything. Science is showing you that that small rat study is so small, it could be anything compatible with what the Argentinians are seeing. That's what science shows you. Not, they show me anything, so I'm not going to do science at all. And finally, this is our FDA, Food and Drug Administration. There is a publication by FDA scientists in November 2007 called FDA Science and Mission at Risk. Whoa. Try to find that online. It has a beautiful picture here, and it's kind of a logo. And I kind of read the article for you by FDA scientists. And I have the quotes, but we won't go over each one. But I will tell you, the FDA scientists complained about the FDA administration to say, regarding GM food, they don't know the science, they're not willing to pay for it, and it's not a part of their vision to go get the science. And it's a horrible condemnation of the FDA by FDA scientists, except for one group, the drug and vaccine people. When I was working with I never worked for them, I worked with them. The World Health Organization was trying to harmonize the US FDA, the Canadian, Australia, Japan, and the EU. And we had a set of principles how to test things. Precautionary principle, you do this and you do that, you do that. And I thought, I was proud of the work we did, drug and vaccines. And the FDA was proud too. And they based their current credibility on that work. And now, I'm the first guy to say, you guys don't know what you're doing with GMOs. But I feel a little bit insulted that all the work we put in, building the credibility, you have used to push this issue. That's kind of personal. Try not to get so personal. The American Academy of Pediatrics called for greater protection from toxic exposures. The pesticides, that's all the road stuff. Yeah, the car we don't know, but the road, the pesticides, you're killing us. The pediatricians called for it first because the kids are more susceptible than adults. Since I gave that presentation to Josh Green's committee, you should see the publications coming out about glyphosate. Okay? Now, my problem with pesticides was always the combinations. You see, 2 chemicals, you get 3 combinations, A, B, and A and B. Here's 4 chemicals, you get 15, you gotta worry about. 15, you get 30,000, 45, you get 10 to the 13th. That's like 10 trillion, no? 100 trillion, 100 trillion. But with 82, it's now 90, it's a trillion. Whoa, sometimes the numbers get so big, it's just like, wow, I can't do that. Sometimes the numbers get so big, it's like, hey, that's like winning the lottery, impossible. No, it's the other way around. It's impossible to come out scot-free without a toxicity when the numbers are big. It's the other way around. Then it's, well, Dr. Pang is pie in the sky. He expects us to test a trillion. I told you, test it like a cigarette. But when the wind blows the wrong way, and you no longer have 90, you are exposed to 80, you better test 80. Because I agree, some of these might block other ones, and you don't know what you blocked or didn't block. It's not so hard to test the soup. That's all we're asking. But never forget, just because you can test the big stew, when you add components in it, doesn't deny the fact that you're adding risk by these different combinations. Now, Tyrone Hayes, the guy about atrazine, he presents about atrazine. I presented after him about the combinations. And what does the EPA? The EPA was there. They stopped coming to the meetings of Rescue. Sit them down and said, your combinations. Isn't it true that 2 chemicals or 3 or 4 or 5 are considered a new compound to proven otherwise? No comment. What did they answer? What was the answer? Well, each one is 1,000-fold what we think is toxic. Yeah, that's each one when you combine them. So I did my homework. I said, hey, look, here's 2, and it increases the toxicity 10,000-fold, 30,000-fold, let alone 3 or 4 or 5. Well, they just kept answering like they don't hear the question, but they stopped coming to the meetings. These are the guys it's proposed to preempt you. When we're on Kauai, you keep hearing that a state's going to come up with a plan. They're going to preempt you. Even now they're preempting. It would be nice if the preemptors were here to tell me how they plan to do it. Now, we have the right to self-determination, but they don't even come here to tell us why they feel they should preempt us to answer the question about combinations of chemicals. I mean, it's really bothers me, as you can tell. All right, here's one thing that really bothers me too. What is a combination? When you combine 2 chemicals, I'm talking about the road now, not the car. Well, This is the first thing. The first thing they say, Dr. Pang, using 90 chemicals. Are you using them all together? I've seen the records. You kind of are. But let's pretend you did. So what's a combination? Well, you spray them together. That's combination, right? What else? You spray them separately, but they persisted in the environment, the dust, the water, together. If you don't think that's true, look at H. Pokowell on Maui. The sugar guys put in atrazine, somebody else, pineapple guy put in something, somebody else put in something. They never put them together. 4 of them are in our water. That's combination. They persist in the environment together for you to drink together. Or they never were put together. They never overlapped in the body, in the environment, but they overlapped in the body together. Okay, that makes sense. And here is the worst of all. They overlap in pathology. That means they never were put together, they never in the environment together, never in your body together, but A, hurts your right eye. And it took you 10 years to fix your right eye. B, hurts your left eye within 10 years. That's overlapping pathology. The environmental people have a field day with this. You know that, well, you don't know, it's part of the suit. The runoff from West Kauai, killing the sea urchins on the reef, 50,000 dead sea urchins, damaging the reef. Okay, that's pathology from drug, whatever, chemical, whatever. Before the reef fixes itself, you hit it with another chemical, that's a combination. Overlapping damage, which doesn't have time to repair. And sometimes the repair is so slow that it really does overlap. Okay? So I want to get that clear, what is combination to me. Here's a group, American Academy of Environmental Medicine, I'm almost near the end, May 2009. Who are these guys? These are 300, last count, probably 400 or 500 by now. Canadians, Americans, physician PhDs. Pretty open-minded, they've been around a long time. They call the health risk on different things like lead and all that. Good track record. And they take a position, you don't have to read it, I just put it up to show you. That number one, all physicians should tell other patients, we really don't know the risk of GMOs. Okay, food. Next, all physicians are supposed to consider any unusual syndrome, quality or quantity, GMO. This is before all the pesticide stuff hit the news. Next, they're asking for a moratorium on all new products until independent studies show safety. It's like, show me the car is good before I drive it. And they're asking that the existing ones that kind of spread out all over, 50% of your papaya that you never intended GMO is contaminated, that it's labeled. These are pretty strong guys. There's only 2 pages to read. The second page, let me see if I got this right. Oh, the second page is all the animal studies. Remember, we haven't done humans. Monsanto admits we haven't done humans. But you look at the animal studies. They claim that this is sufficient to show cause of harm of GMOs just in the animal studies. But mice are men, mice and men are men. But when, you remember I reviewed stuff for the US Congress, human trials. Don't you think I review all the animal studies that led to it? If we saw this kind of animal studies, the trial would be unethical. Okay? So I don't like a double standard here. Okay, now we get right to this thing here. Your answer. So are we gambling with our future? The answer is, well, when we gamble, we know the odds of winning and we know the odds of losing. With GMOs, you have no idea on the odds of losing. So this is not exactly gambling, it's worse. Next, when Jim gambles, okay, and he loses. How would you like him to gamble and every time he loses, I lose? Oh, what are you talking about? I'm talking about contamination. If, now you see, you thought I was so near the end. You look up Bear LL601. That's a GM of rice that was experimentally used in the field not to be released. It was used 3 consecutive years, I forgot, 97, 98, 90, something like that. They pulled it back, proved. 5 or 6 years later, massive contamination of the long grain rice in the US. That's like, he gambled, that was his, he wanted that rice, and I got affected. That ain't gambling. When they tried to figure out how the rice got contaminated, field, silo, seed, they could never figure that out. The damages on the investigation and the missing market, 1.2 million, they went to sue. And what did the company and the federal regulators say? Act of God. Act of God is like Katrina. You see the hurricane, you know it, you couldn't do it, fix it, so that's the act of God. You don't even know the cause. So of course the judge said, well, what does that have to do with anything? So they never figured out. And in the search for Bear LL601, they found that there was contamination with another one, Bear LL602, or maybe 3. Gee, you didn't even know that one was contaminated. But here's the funny thing. The long grain rice lost the market, Louisiana, Texas, and all. Said, oh, okay, lost it. Next year, we want to plant. Okay, so they pulled the seed to plant next year. That was contaminated. The long grain rice guys, by the way, this is sustainability of farming. The long grain rice guys said, how did our seed get contaminated? We're going to plant. Well, Europe ain't going to buy. Well, we're going to sell it to America. I don't know how that was settled, okay? But you see this mess that another contamination was there. The seed was contaminated. The guys in charge who let the seed be contaminated, the regulators said, you're not planting that contaminated seed. Well, you're the guys who kind of did lousy regulation in the first place. And so that's the end of the study. I just have to point out some of the things, what we call industry say. They don't say it to me anymore, but they'll say it to anybody who will listen. Remember, first of all, it's natural. Well, yeah. But here's a lot of things: hepatitis B, water, salt, oxygen, tobacco. That's natural. Okay, too much is too much. Irreversible effects like cancer are irreversible effects. Next, no harm, no foul. We went to court, and they were putting pharmaceuticals in our sugarcane to harvest the pharmaceuticals. And they sued, or just sued, and the judge said, that's correct. Now, don't do this anymore, you have to divulge. And when you divulge, trust me, like we blocked the GM algae in Kona, we blocked it. But we had no idea what they were doing until they were forced to divulge. So the industry said, yeah, okay, we won't do it anymore. But remember, Judge, no harm, no foul. That means we didn't cause any harm, so don't criticize us too much. First of all, my position is, I don't know if you caused harm. Okay, I don't know where that stuff is now. Okay, number one. Number two, the judge, Seabright, a federal judge, who said, don't say that kind of stuff, no harm, no foul. You were damn lucky this time. Okay, the next time, by the time you see harm, it's out. Okay? But that's a typical thing. In fact, many politicians will tell you, I'm not going to do anything till I see harm. The harm might be irreversible, like papaya contamination in Puna. The harm might be irreversible on individual level, like cancer. By then it's a little late. But with that attitude, we don't even talk precautions. Okay, you're not going to do anything until we see harm. Okay, we covered all these other things, qualitative versus quantitative audit. Not all unintended effects are bad. The precautionary principle, that doesn't mean everything's perfectly safe with certainty. Yeah, so what? That's not the precautionary principle. And Dr. Goldstein from Monsanto twice. You remember he said, you gotta test these things and put the guy away for 30 years and feed him nothing but GMO, so it's really strict. Well, what did Dr. Goldstein say about Serenini's study when he combined, it was a drug, not a mutation, when he combined glyphosate and the surfactant. And he said, whoa, each one is alone is safe. No wonder EPA thought it was good. But when you combine and check the effects, what did Dr. Goldstein say? Besides, everyone's using detergents. What's the big deal? You could be hit by lightning. Dr. Goldstein said, well, that's in the lab. That's not real life. So on the one hand, the lab is not good enough. You got to go to real life. When we come to real life, he's telling you, put the guy away for 30 years. And what he says is actually true. Neither of them want, neither real life or lab is good. That's why we always require both. He's saying neither is good, so he requires neither. That's really strange. Okay? By the way, it's kind of very interesting. The guys who would defend GMO stuff, tell them quote Dr. Goldstein from Monsanto. And we'll just kind of leave it at that. Now, one more thing, then I'll let you go. Can we turn the lights on? When we went for the Maui initiative to put a moratorium on these GMOs, the Farm Bureau came out with these statements why this is a dumb bill. And the thing that's so upsetting is, says right here, I'll read it for you. Approximately 3 trillion meals with GM ingredients have been consumed without incident. Again, 3 trillion meals with GM ingredients have been consumed without incident. I posted this on the International GM Lister. It's a dark thing. Don't waste our time with things we've discussed many years ago. They said, you defended yourself. 3 trillion meals have been consumed without incident. You mean to tell me, after 3 trillion GM meals, nobody went to the emergency room in 2 weeks with a heart attack? Nobody was diagnosed with cancer in the next 6 months? You mean that? No incident? You mean, no really, nobody dropped dead for unknown reasons within 3 trillion meals? They said, no, of course we don't need that. Meaning compared to normal, compared to control. Where's your control? It's not labeled. This is a classic study. Even Europe says that. Where's your controls? So that's a kind of weird statement, number one. And number two, if you're really going to make that statement, tell me the uncertainty intervals. Because you certainly didn't have 3 trillion people who ate non-GM meals to compare it with. It's not labeled. Next issue. How many cigarettes did we smoke before they figured out and published that it caused cancer? We did this in 1950 at my medical school. Not me, it was before my time. The Oxford brothers from Tulane. In 1950 said, you know, that thing does cause cancer. 1950. How many trillions of cigarettes did we smoke that we didn't see yet? Trust me, more than 3 trillion. And the worst argument of all, which really bothers me, you see, this 3 trillion meals is in the last, 20 years? If that is your argument, suppose God tells you that's true. Never mind all your control group. It's true. There's no harmful effect. That's what we know now. 20 years ago, when it was released, and we didn't have this 3 trillion argument, you didn't know, did you? No, we didn't. There's only one way you can release an unknown product. That's informed written consent. And when you have the informed written consent, you will tell me the benefit of this product. This is to save the world, to make more food. Not really, you're going to feed for animals, okay? You will tell me the risk. They will honestly tell you, we don't actually know. We never tested in humans. And based on that information, they will tell you, we want your consent to release this into your community. Your next question, believe me, I've worked with these ethical committees. What happens if something goes wrong? Go ask the regulators. Are the regulators here? The regulators are going to preempt us, trying, federal and state. Ask them who bears the liability if something goes wrong. At least come to the meetings. Okay, so we'll leave it at that. I'll take your questions. Sorry, if you said, I'll repeat the question.
The 90 chemicals, are they all on the market now, or some aren't?
Okay. The 90 chemicals, we just got our handle. I didn't even know it was 90, okay, until this. The question is, the people around the community, they're afraid of drift, dust, fume, blah, blah, blah. Other people are worried about residue in the foods. Go to ABC News, Diane Sawyer, who calls in Richard Besser, who used to be head of CDC. What does Richard Besser say about our food? The main risk is pesticide residue. Some of it can't be removed. This is the former head of CDC saying this. I don't know of the 90 and all its combinations what is persistent. There are studies since the Josh Green testimony that a huge chunk of our population is carrying glyphosate. Either we accumulate it till we spill, or we just get it and spill it. We were never supposed to have that. Now that we have it, Europe claimed as a more sensitive test, 90%. Moms against Monsanto. My mothers, they did their survey nationwide, and 30% of about 150 tested. So, whoa, we don't know what it means. We don't know the level that's safe or in combination. We don't know how they got it. These people were trying to be organic. So, well, it's one thing to say it's safe. The other is another thing to say, well, even if it's not safe, you're not exposed. Now we have both kinds of studies. Plenty of people are exposed, and the animal study showing us lots of strange things. Yes?
Well, a lot of us here know how much money is spent on the military. But I just read the other day that 20% of the budget goes towards medical costs, and that's just a fraction of all the money that's being spent on medical stuff in the United States. And do they ever consider how much that is? I mean, I understand that some of that's going to insurance companies and stuff where that money didn't go before, but I mean, just this accumulation over time, there has to be reasons why it just keeps going up and up and up, and some of that has to be, the GMO being introduced into the diet has to be part of that equation.
Okay.
Do they ever try to work
Yes.
out,
First of all, you have to say what you think is attributable to the GMOs, okay? Now, not the car, but the road. Dr. Seneff from MIT and her colleague are beginning to publish these strong correlations between autism, which is very expensive to treat, and the use of glyphosate, okay? They just published the other one on celiac sprue. All the guys can't eat with, and the glyphosate. And so, she's beginning, the MIT, backed by the MIT lab, very powerful statements, okay? In general, these are called ecologic studies. We use more, we get more disease. That's not quite so definitive, but the correlation is stunning. Just because it's Easter, just to be entertaining. I'll tell you why it's not so definitive. There were two populations, Protestant and Catholics. And he said, oh, you know what? In the Protestant community, the suicide rate is higher than the Catholics. Therefore, Protestants are more prone to suicide in the community. But when they actually went into the community, it was the Catholic minority who was committing suicide, living amongst the Protestants. So you got to go into the data. Easter. That has nothing to do with Easter. Okay, so you got to go into these ecological areas and find who is who. Immediately, what does the industry say? Autism's rising, and so is glyphosate. They said, oh, you know what else is rising? Organic food. Organic food. Why don't we go into these autistic kids and say, what do you eat, organic or not? You have to go into it and sort it out. But the correlation is so stunning that I think Seneff from MIT group is correct. And she has a very good biomolecular model. Why? Problems in the gut from glyphosate, the road, not the car, can give you autism.
So his question though is related to, are there, I think, if I understood, are there data and research and evidence that's showing why our healthcare costs and illnesses are mounting and mounting in relationship to the presence of GMOs?
No, but when you have elevated cost, you got two things. The rising cost of just plain medical care, insurance and all that, and the rising amount of illness. They're claiming, the MIT group is rising illness, let alone the cost. Okay. But we haven't partitioned that out yet. But they claim it's related, Roundup is related to obesity, depression, autism, celiac sprue, just a list after list after list, and I think they're right. Yes.
I can remember when correlations like this had been shown definitively for cigarettes, and it took decades to convince people who the science show me anything crowd, and they're everywhere, convince those people that there really was something they had to do. They couldn't just sit back and watch this, they had to act, because it wasn't just a correlation, it was a causality. It took so long. I guess guess I'm kind of asking a strategy question. If we're trying to do something here, should we go that route and just keep pushing until correlation becomes a causality, even for the doubters? Or should we try to take the tack that you used in a lot of your talk, which is, look, the methodology these guys use sucks. If I compare it with what anybody would expect in the health field, what they're doing is so bad that we should argue against it without proving harm. You see what I'm trying to ask?
Correct.
That's, both these arguments are really hard to make. Where should we put our effort, or is it we have to do both? Or
I think the best example we can do is drugs and vaccines. When we release things that we didn't study, we have hell to pay. Not only that, but we release them, you wouldn't dare release them unlabeled, unmonitored for recall. 50% of our drugs, 50% of the drugs we release, we see serious side effects after marketing. 10% of that we recall. So, you know, the issue of causality is getting very fuzzy. So the epidemiologists have, it's called Hill's criteria. If you actually pin me down and say, you can, in fact, the tobacco guys say this, you cannot show me how tobacco causes cancer. You can't show me, and it's called deterministic. It's like billiard balls. I can show you the tar is related. But the other people, it's called Hill's criteria, strength of association, temporal, this occurred before that other people can repeat the findings, dose response, and there's kind of a biomolecular mechanism. It doesn't say you have to show. And that's why the American Academy of Environmental Medicine, at least for animals, said cost has been shown. These things are dangerous for animals. So, even worse, look, if you really want to see something fantastic, read TGN 1412. I put it up there a few times. I'll leave this with Blake. TGN 1412. That was a genetically modified product made in bacteria and done correctly, given to 10 humans in the UK. That made front page news in Honolulu, Star Advertiser, Star Bulletin, because medical people have never seen such bizarre side effects. Okay? So we didn't know, we thought, what, it was that. So they didn't admit it was GM. New Zealand said, this is GM. The company said, you're right, it's GM. What did the company say? You talk about causality. One hell of a contaminant, wasn't it? When they see stuff they don't want to see, they claim it's contaminant. The German government pulled the process of making TGN 1412 and said, we don't care what you call a contaminant or horrible side effect. It was made to the correct recipe. So if it's a contaminant, it's inevitable in the product. That company, Tangero, folded. You think they folded on their own? Or you think some other big company said, shut up, don't rain on our parade? Many companies have folded. Don't rain on our parade. You're going to screw up. Don't embarrass the whole car industry. But there's so much money flowing. Science will never truly show cause in many things. And we always do is association, timing, dose response, reasonable biomolecular argument. That's what MIT has the strongest now. The biomolecular argument, why this stuff is causing all these modern diseases. Stunning. Her name is Senate. She gave testimony in court. Yes.
Yeah, sounds like you get two arguments here, or two issues. One about Roundup and one about GM.
Correct.
So putting them together doesn't seem right.
Well, that's what the industry.
Two separate issues, right?
Okay, no, well, actually, it's the car and the road. It's the car and the road.
One for GM and one for Roundup.
Why do you
Why you put two of them on the same road?
Because GM crops cannot survive without 90 chemicals. This would, GM crops are intrinsically, from my knowledge of genetics, you put a gene that doesn't belong there, the first 10 years it's so weak, normal germs, virus, blah, 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 will kill it. You got to sterilize the ground. So you got to put the 91, it's almost inevitable you have to use 90. The industry says, I can't win the mutation argument, so I'm talking about chemicals. I'll say your lack of, not your, but their lack of precaution for the mutations shows up again, this lack of precaution with a combination of chemicals. I mean, a lousy company, a lousy regulator will lousily release things, both in mutations and chemicals.
Because Roundup is so widely available for cheap now.
Yes.
It's so effective in controlling unwanted grass.
Okay.
So, you can control the Roundup and GMO fires has nothing to do with Roundup.
Correct. Tell me what other chemicals are used with GM papayas though. It's not just, Roundup is the forefront because it's so widely used. But don't forget, the system itself, the road might collapse because of the Roundup resistant weeds. We learned this with antibiotics. The system will collapse. But in the meantime, while the system's collapsing, or you might win, where's the personal responsibility? People are claiming they're sick, although the system is saving the world or whatever. There's still that personal thing. The drift, the residue.
Doctor, I think the gentleman here has something to say.
Sure.
I just want to ask your opinion of BT crops, specifically not herbicide tolerant crops, because obviously the situation on why pesticides are testing in reference to none of that heat, but the whole commercial selling point of BT, as far as I can tell, is that you let pesticides on it because it's built in.
Correct.
So do you think that might be potentially a good use of technology with it, compared to?
Okay, the question is BT, Bacillus thuringiensis. It's a chemical allowed by organic farmers, and they can genetically modify it and put it in the plant. Now, you remember, that stuff from the Institute of Medicine was unintended effects. If BT is truly BT is BT, well, that's one thing we can talk about BT. Of course, the amount they put in is expressive. But in the mutation insertion with the promoter, I do not like eating plants with loose promoters, BT or nothing. If you say, well, what's wrong with that? The gene therapy guys, remember, they wanted to give the boy the gene, but the promoters turned on the leukemia. If you think these things can go from plant to mammal, well, so can promoters. I am horribly afraid of the promoters.
So what about when you eat like food with all the I mean, it's all mosaic, right?
Correct.
Food that has that in it.
Correct. This was one of the arguments for Dr. Pang. The common promoter for GM plants is cauliflower mosaic virus piece. And that occurs in some cauliflowers. It's got mosaic virus. But I'm talking about quantity. I'm going to give you the water argument. Too much is too much. And I can give you a biological argument. When you mess with my gene, when the genes are messed up, they have a repair mechanism for the mutations. Well, that repair mechanism can repair at a certain rate. But when every cell is got a promoter, that overwhelms my repair mechanism. And I'm not saying it's true. All I'm saying is somebody better test this. Because just because it's natural doesn't mean the location and timing is correct. Amount.
Just to follow up with that, the promoter region is a defined sequence. It can be sought after in the genome and sequence when they do this. And check to see are the flanges of either side of the promoter to make sure it's always in place with the
With the piece.
And they check that.
Okay.
So it's not everywhere.
Wait, this is published in Science, right?
Yeah, I mean, we could do this in our lab. Anyone can do this. To check to see if this promoter is in every cell or in different places in the genome. And the promoter itself is a defined sequence. So you can run a sequence either way based on that promoter to see where it's attached within it.
And is it consistent over time that it doesn't move? Because what I read in Science was that the thing seems to move, the sequence itself, and the separation of its promoter. Now, I know you can detect it, but at least the medical guys say it must be always there. There's some there and some there. A loose promoter is a strange thing. Furthermore, you have a conformation three-dimensional folding. You got a construct
which shouldn't be there. Tied to a promoter, I don't know what to do with an extra trombone player in the band. I'm sorry, in the football team.
Promoter is what, 26 bass pairs?
Hey,
I mean,
it's small, but some small things are stunning. I mean, Down syndrome and all, these markers can be, oh yeah, you picked the wrong target. And I will claim that precision is everything because our markers, the glycoprotein pump that we share with the earthworm, that's a specific point. And we should look at the promoter on that to see the specific promoter.
okay, I'm pretty sure that's bad enough. We can check. I'll get back to you next week. I'll write to you.
Yes.
I say about the promoters, this thing doesn't make sense to me because I'm afraid of a promoter. A plant might have 30,000 genes, it's got 30,000 promoters. But if you're afraid of one promoter, I mean, why aren't you afraid of the other 29, 30,000?
Because,
Is there,
okay, the question is, why am I afraid of one promoter that's put in, but the plant's got a whole bunch of promoters? Okay, because normally I can eat cauliflower with the 30,000 promoters. The promoter selected for the transfer was selected to cross species. It was selected. If it's not such a big deal, why didn't they just get a normal promoter to put it in? It's a selected promiscuous promoter, and it was shown to cross. And it's also the amount. I don't mind one cauliflower.
if it was a plant promoter from beans in, and then you transferred it into tomato, would that be okay?
The plant promoter was shown
If it
to
was a-
transfer to
if it was a plant promoter.
mammalian cells.
No, if he was, you're concerned about 35X in tomato, say. But what if it's a bean phaseolin promoter and you put it into tomato? Would that be a concern?
Well, Willie, if you took a bean promoter,
Yeah.
put it in the tomato,
Yeah.
I will claim that it's promiscuous now in the tomato. It doesn't belong there, and it wants to move out to me. It should be where it belongs, with the beans. And I don't know if we classify that as intended effect, because promoter is supposed to do that, or the truly unintended effect of the spacing and the orchestration. Just the spacing issue, no matter how small it is something strange about it.
I disagree.
Okay?
But this is not my part.
Here's an experiment for you, because this was publishing out of Science or Nature. The fern was discovered to have a gene from the, what is it, algae or fungus?
Happens a lot.
Yeah, and it took 100 million years, okay? And the ferns that didn't do well, you don't see them anymore. Take the gene out, put it in your modern system, put it back into the fern. Tell me if the success rate and the reproduction rate is normal like the fern.
Probably.
I'll bet you it's not.
Well, can I say, like in corn has these transposable elements. They all do, and they just jump around from place to place to place to place to place.
Yeah.
But we still eat corn, and I'm sure you're not worried about these AC and DS elements. I'm not. I don't think anybody should be.
I'm not worried about non-GM corn.
Yeah. No, they're not GM corn. I'm not talking about South American corn. Just regular corn has these endogenous transposable elements. They've been Barbara McClintock got the Nobel Prize for discovering.
But are these transposable elements or the elements, do you think they're exactly like when we genetically modify corn?
They're worse. They jump around more,
And
much more.
There's
than when we
thousands of them in our cell.
transform
There's huge numbers of them moving around all the time.
Well, I would like to see them jump into mammalian cells in Dr. Travik's system.
You know those Indian corns with all the different colored kernels?
Yeah.
They look that way because of these transposable elements just getting into the pigment genes.
Okay, so they jump amongst themselves.
The point I'm trying to make is that these elements that move around in genomes, we shouldn't be afraid of them. They've been around they've been around forever.
Tell me about the addition. If there's A and B can switch to B and A, but you put in X, no matter how small the promoter is,
Yeah.
isn't that kind of like a different spacing somehow?
Yeah, it is.
If you're going to put in something new, can you take out something old? At least give us the same spacing. And when you take out something old and put in something new, are you putting it in the space that it would take. Look at the medical community. We can't even put a human to a human without causing leukemia.
The point on leukemia is very interesting, but I think there's a misunderstanding here. The reason that it causes leukemia in those tragic cases is because you would take some bone marrow from the patient, from these little children, and take hundreds of millions of these individual cells and treat them with the virus that carries the repair gene to make the immune system work properly. And in 99.999% of the cases, the gene lands in a completely benign location. And if that was all that was happening, the descendants of those individual cells would have cured the children. The problem was that when you put this into hundreds of millions of cells, each one with a different landing position, on incredibly rare cases, but when you use 100 million, it's a certainty, some of them will happen to land next to genes that control cell division and cause the cancer.
Problems.
And when you put these hundreds of millions of cells back into the patient, those 1 or 2 bad cells will give rise to leukemia. The other 100 million would have cured the child. They stopped the test because they didn't have a good way to select away those few bad insertions. But now they do. So it wasn't that the 100 million cells that got the good locations, those cells were bad because they continued to jump around and things. That wasn't the case at all. It was a very, very few rare cells that the transgene landed next to a gene that controls cell division. They don't move anymore. They stay there. So it's not that transgenes continue to move around or the promoters do some weird thing. It was the insertion site of those very, very rare cells.
Are we talking about the New England Journal of Medicine article?
We're talking about skids.
The what?
Skids.
Skid, yeah. In New England Journal of Medicine, they were predicting
there was many
the probability was 4 times dumb luck of hitting the
No, it's basically a certainty. So that's why they don't do this that way anymore. Because if you put a transgene in 100 million cells,
something will go wrong.
There's a certainty that one of them will land next to an oncogene. So they don't do that anymore. They did the experiment at tragic results. They figured out why, and so they're not going to do it that way anymore. But it wasn't because the promoters are promiscuous and jumping around or anything like that.
But it was because they didn't exactly know where to put it in a couple.
That's an excellent point. And so now, that was about 15 years ago. So now, when they're trying to do genetic engineering again on gene therapy on patients now, which is very rare because it's so difficult, the first thing they would do is check where the transgene landed in the genome. It's very easy to do. And would not put the cells back into the patient unless it was in a benign location.
Okay. So I'll look at that subsequent stuff to show that it was stable. They just chose the wrong spot. Okay.
One of the things is that you make it sound as if there's all this scientific work being done and therefore we can address the problems with genetically modified organisms. But we still have this theory of substantial equivalence, so that as far as the regulators are concerned, these health and safety tests are not being required. So you have the Monsantos who hide behind the patent law and all of the intellectual property laws so that the science is not done. So you basically, where everyone says, oh, look at all this science, why aren't you pro-science? It's all of the industry that's able to politically maneuver and circumvent doing the tests that one would do for an additive of some, whether it's a color or some, something else. And then plus, you have all of the patent, all the ways you could, if Hector Valenzuela wants to do some study on genetically modified tests or on pesticides, it's no. We don't want to give you that information. They control that information. And then plus you have the independent, the one international foundation that was doing studies on bees and the harm from glyphosate, Roundup, on them. It was bought out by Monsanto. So that's the wall. I mean, it's great that there's progress being made, but I think also, like, to your question, and what way do we go? I mean, at least the Supreme Court has said where you have a high risk, you have potential irreversibility, that the government should not be required to sit and wait for definitive science. And that the burden of proof is not on the people, not on the government, it's on those who want to utilize that, utilize those mechanisms. So I think that's what our county did, was just say, we're gonna proceed with precaution, and we don't know. And it's all this, here, all these science, we've done all this science and found that, our Monsanto tests show that there's no harm. But really, Kauai is the test. What happened in Peru is the test. What they said was the communities where it's all GMO soy and all GMO corn, all these people are ill. And over here, all these communities that don't have it aren't ill. So it's sort of like, if you then go to the FDA or Department of Ag and said, well, what about post-marketing testing of those whatever the GM stuff that's been unregulated or no longer or approved? And they say, no, we don't do that. So you basically, for me, looking, how can you be a responsible government official? You look around the world of what is happening, and not just to the people, but for me, that whole web of life and the soil and the health of the soil, and you say, hey, I don't want to get to where we're in the middle of Kauai. I know, like Lucas, we have plenty of people employed in this, but do we want to really get to where taken over and be GMO dominated? So it's that concern, it's that risk. And if you're a scientist, you sound like you know a great deal. It's really who's putting up the wall to the science. It's that political wall.
So with like the root resistant, the rootworm resistant corn being used on the mainland, that's had adaptive mammal transfer, horizontal gene transfer, correct, of the resistance. What does that mean exactly? So you have the rootworm that can eat the corn now. That was originally not able to do that. So does that mean it's taken up all of the genes that were originally in that, including the marker and the promoter, or is that just a certain resistance to a particular part or a particular quality of the genetic modification, or what does that mean exactly?
I have no idea. When you see the question was, when a pest, the rootworm corn, gains resistance to the pesticide, did it get it from the plant or just develop it de novo on its own? I don't know.
I know.
Go ahead.
I've been working with lots of insects throughout the past 10 years. And with pesticides, that's the problem, is you will have a susceptible population of insects that aren't affected by the toxin anymore. They're either have some kind of mechanism to detoxify it, break it down, or pass it to the gut system. I don't know how the corn rootworms, that population has become resistant to that toxin, but it happens naturally because of the natural systems that insects have to deal with toxins in plants, that plants are very toxic to things. And those corn rootworms, there's essentially no way that the BT toxin gene could transfer into them in a way that would then make them resistant to that toxin. They're different things. So it's basically killing 100% or 99% of the insects, and that 1% that doesn't die is what comes back next year. And that's why there are huge numbers of studies to look at the minimum reservoir population to not kill with pesticides so you don't build resistance. And those recommendations are all available and recommended for corn, all pesticides. I mean, I've got the big stack right here. And as long as you can follow, you reduce the risk of populations of insects that then will survive that pesticide. So that's how that works. It has nothing to do with horizontal transfer of that BT toxin from corn into the water.
Yeah, it would have to be the transfer of the BT resistance. This is just BT.
No horizontal transfer. That's not the mechanism of resistant populations. Doesn't happen.
It sounds like he's possibly talking about organic farming. I just want to comment earlier on what this gentleman was talking about. We're farmers here on the Big Island, and I had a neighbor farmer of mine who was a papaya farmer right here in Puna, and he passed away a few years ago knowingly from exposure to too much spraying. And knowingly. He knew, he was aware, he shared this with myself and with others, and he sprayed his whole life. He grew up in the sugarcane industry, and I sold goats to him and his family for their weddings and their birthdays, and he sprayed too much. And so the conversation is, it's such an interesting thing, these GMO crops, where we're putting so much energy into them and saying how there's all these arguments for them, and yet they only exist with a minimum of 45 chemicals, up to 9 chemicals. They only exist that way. I mean, how can we choose to farm this way?
They don't exist. They survive
well,
without being sprayed.
I'm growing.
Have you been
without spraying anything in perfectly dirty soil that has 0%
enough to feed large groups of people?
The question is for how long?
Well,
That we just need to know how long you can do that.
you grow in the same way. You could grow GM crops organic, using organic methods if you want. The regulations that you can't do that. That's just what we do. But I mean, you grow Roundup ready corn in the organic fields. It's just going to grow like
But then you can't save the seed for the next season. That's a problem.
well, it's illegal if you're in contract. But
Or if the Terminator gene is in that genetics.
They don't release it.
You know, we have the same issue with antibiotics in treating germs. And you could ask the same question. We're using chemicals to treat germs. And you could ask, well, how long are you going to do that? Well, resistance really developed, okay? And so we have funny rules that you really got to control the use of antibiotics. You really do. It's a certain time. Everybody's got to take the germicidal dose. You can't give a half-assed dose. And we have tight restrictions. And lo and behold, when we went to study development of germ resistance, we found that the egg guys in chickens were putting these antibiotics in chicken feed so that some germs were exposed to sublethal doses. Now there's a publication out from Boston University. What exactly sublethal doses do? It just mutates against all targets. So at least the medical guys face the same problem where we're strictly trying to control the chemicals for well-targeted groups. The plant guys, you're putting BT into the plant itself. I mean, some germ's going to see, some insect's going to see half a dose, and then resistance develops.
One of the experiments done in Peru with corn, they plant GMO corn in 2 different types of soil. One to a ratio of 2-to-1 and the other one 4-to-1. And they grew differently, one bigger than the other. And they experimented on people, and the people they ate of one have more level of toxicity, intestinal tract failure, totally mess up the intestinal. And they ended up with even different tumors. At the end, they died. So that was one of the reasons why the government decided to ban this GMO. I mean, the corporation is so powerful that they imply, the government has to say ban for 10 years. Not like permanent, because they were all kind of threats. They were.
Yeah, there's studies now. I'm not sure of the mutation, if it was BT or glyphosate, but there's studies now. Judy Carmen out of Australia, large number animal studies, change in the gut appearance, inflammation.
So one of the
mutations.
One of the conclusions was the science investigated because they say that based on different types of soil, the mutation was rapidly multiplied to the really intense.
That's one thing I want to bring up with the gentleman in the back, that the corn mutations are jumping all over. You put in a new kind of mutation, you study it seems to be stable. How long? And under what conditions? And when you bought the farm, how do you recall it? Church asking how are we going to recall? My issue with the GM papaya was always the marker, glucuronidase. Glucuronic acid has been shown in animal models, 7 cancers, 7 animal models. Glucuronidase breaks it down, okay? And they're trying to remove that, but it's all over.
So that's also including companion insects, companion elements, different chemicals on oxygen, water. It's uncontrollable.
This is not like DDT. It has a long life, and you can stop it, and it slowly decreases. This is a life form, and the argument is whether the life form is selected for or not selected for. I was hoping it's not selected for because it's a mutation, but all your arguments is telling me it's selected for. But we see a dual nature with drug-resistant malaria. At first, it's weak. It's drug-resistant and it's weak. You got to use the drug. After that, it's called stable resistance, and it will dominate. So, this is a life form. It's like, to me, it's like Cokie Frog.
Also
Little red fire.
Plants, they need copper, iron, boron, zinc. All of these elements also mutate. And in combination with the GM element, they're going to go off. And it's a proven science. We already discovered it. It's not safe to them.
The other issue is if you believe GM corn is no more dangerous than regular corn because of the transplantation, ask the Institute of Medicine to address it again. Because to go ask them family, knowing now what we know. Because their statement is unintended health effects. And it's not the same. It's not, oh, by the way, that graph I showed you? Not only is the average higher, and I don't even know the scale, but the inconsistency is higher. The spread of the curve. The inconsistency of the plant. It's Institute of Medicine.
Right.
So, you're always asking me, where's my publications? Bring it up with them. They don't need publications. They'll give a new ruling based on new evidence. That's fine. Yes.
It's past 9 o'clock now, so we need an agreement. Maybe a couple more questions, and maybe.
Sure.
Maybe 2 more questions, please, and then thank you all for being here, participating. And thank you.
What would you say is the highest risk of what should be labeled for manipulating genes and for food crops?
So the question is, what should be labeled first?
What is the most important gene modification that geneticists use to start breeding and to select for new crops and get new genes into the market? What is, which one do you think should be most important?
I don't know. I would ask for the animal studies again by the American Academy of Environmental Medicine, which ones they saw the highest animal stuff, because we don't do human stuff. We should do human, but I don't know. But if the issue is which one should we label first, I'm actually against a little bit against labeling as only the fallback position. Because with drugs and vaccines, when we have something untested, we don't say, well, it's okay as long as you say it's untested. The first time we did that was with kind of toy, toy or something. We labeled that, this could cause problems. I don't want to say label it because then it authorizes many things untested to be sold. And a lot of providers don't read it anyway. I think we should do it correctly. By what? My definition? I don't have conflict of interest. You ask the other people who have statements, direct or indirect conflict of interest. I'm not. I have a book. This was the major, it's published in New England Journal of Medicine. A lot of people coming from industry are quite senior. The funding is with industry. And the senior people, they said, this is not GM, this is pharmaceuticals. We are so senior, we can put aside our conflict of interest. Published in New England Journal of Medicine, not the reference. But these people, according to the voting records, either lying or deluding themselves. They cannot put it aside.
According to the graph that you showed earlier, that stated the difference in possible health effects of
yes.
If I remember correctly, according to that study, the most dangerous one is radiation treatment.
Correct. Correct. Correct.
Should we label those?
I don't think we do that too much anymore. And the ones that have been generated by radiation, you have to ask Hector about that. There were some problems with that. Some seem to be pretty good, the things that we form by radiation. But we don't do too much of that anymore.
White rice, no meat, the white rice. But what percentage of that was made with insensitive, radiation insensitive? Tell us that in six.
Okay.
Why we planted rice in California? But we didn't have race, same thing.
I mean, that's correct. There are some examples, but there are some examples of things that didn't make it. Okay. But there's plenty of examples of stuff that didn't make it. And you remember, if you tell me Calrose rice, look at the history, I'm going to say, yeah, okay, you're right. But 25 years ago, when we lined it up with the other stuff that wasn't so good, sorry, but I didn't see it in 1%. When you use historic data to prove and screen out, to say, see these winners, I'm going to say, well, where were the losers? And where was the rigging and form concept?
I'm not necessarily convinced that white rice is the healthiest food.
Okay, but, yeah.
But the same thing happened with lead. I mean, they even had congressional hearings where, they lied before Congress. And they knew that lead was dangerous and came on children's toys. And they lied to the people, the American public. So I kind of put this like with tobacco, as you mentioned, lead. We all were led to believe that it's safe. But I kind of feel like we take the precautionary route because we don't know. I wanted to ask you, what do you do?
Me?
Yeah, and your family.
Well, first of all, I don't pay attention because my wife does. And she's furious about this issue. And she really is furious about the chemicals. Okay? So as of last 2 weeks, she called all her friends. And she really put her foot down. She's a PhD, cardiac pulmonary physiology. And she is very upset about the pesticide issue now. But don't say, please, you can't win the mutation issue, so you jump to the pesticides. It's kind of like, you've never figured out the ignition on the car, so now you're addressing the brakes. You guys can't make a brake or an ignition and test it correctly. I just address what's out there.
What about the difference between Roundup and glyphosate? What I've heard is that actually they're finding, glyphosate is the active ingredient.
Correct.
In Roundup, but that actually where they're testing using Roundup and whatever else is in there is having a higher toxicity or a higher harm than just even doing the active ingredient of glyphosate.
Oh yeah, that would be, right? Now, glyphosate is an active compound, the pathogen compound, on Roundup. The Roundup, I think there's many dozens, 20, 100 formulations of Roundup. So I want to know in the Roundup, what are the surfactants? What are the other chemicals that enhance? You will see Roundup studies, one refuting the other. In drugs and vaccines, this is called GMP, good manufacturing practice. You can't really do studies until you're consistent about the product. The variation of Roundup, 2 different formulations, especially when they show the combinations have synergistic effects, then you're going to ask, what are the other chemicals in Roundup formulation?
I didn't realize that there are different formulations of Roundup.
No, I think there are plenty. Plenty. Okay.
Thank you, everyone. Thank you for being respectful. Don't forget the 19th is the debate. Excuse me, 19th is, we got a couple of announcements. The 19th is Hayes, and the 29th is the debate. So your 19th. The 19th is at 7 o'clock. Tentatively, next second will take it.
And can I make one other announcement? On the 22nd, UH and County of Hawaii were putting together a symposium on soil health and composting and how to have quality composting as well as alternative animal feedstocks and biomass. Sort of a whole brainstorming session, some speakers, but a lot of attendee participation.
That's May 22nd?
May 22nd. So it's sort of round table. It's not debate. It's, sharing ideas and knowledge of all those on the island. Maybe at some point we can take some of the food waste and solid waste the county has and actually try to get more of that back to the soil and back in a safe form. It'll be here, but I don't have on the May 22nd, it'll be like 9 to 4:30. Bruce Matthews is helping set it up. And I forget what room it is for the
One more quick announcement, Jim. Yeah, this week from today, on the 26th, it's the Mary Monarch Parade in Hilo. And there's going to be an Aloha Aina contingent in the parade. Positive signs, so concerns for saving Mauna Kea, saving Puakoloa, banning GMO will be part of that too. Any issue that relates to Aloha Aina, come join the Aloha Aina contingent. The meeting at 9:30 at the Kamehameha statue in Hilo, week from today, Saturday. Okay, big thanks to Dr. Lorrin Pang for being here tonight. Step in the back. I don't know if you want to stay for a couple questions personal. We should table it for a few minutes and we're going to start cleaning up. So thanks again. Happy Easter.
I know, it's way past my bedtime. 13 minutes past my bedtime. Really? Oh, God. Oh, you're not yeah, you got And I would get out of well, shall either the county set up or if they're not going to set up. But I'm just saying, if I would say, well, if our county's going to
The stuff we do, you say, we know this now.
I mean, they don't, but I'm not trying to say, the county.